As we said in the previous video, anytime we learn about one sugar, like D-glucose, we get two for the price of one. Because if we switch all of the chiral carbons, we end up with, it's an enantiomer pair, in this case, L-glucose. Likewise, L-glucose can be converted back to D-glucose by, same thing, switching all the chiral carbons. By the way, I haven't taught you how to tell whether something is D or L yet. There's a special rule for that, but I'm going to hold off on that because it sometimes confuses people. So let's move on and talk about other ways to create sugar diversity. First of all, I'd like you to pause and do a little exercise like we did earlier. Let's start with D-glucose and transform it into this sugar. What changes chemically from D-glucose to this sugar? And let's do the same for this one. What changes from D-glucose to this middle sugar down here? Let's have a pause and we'll return in a moment after you've sorted those out. Okay, let's take a note at the first one where we go from D-glucose to this sugar. I can tell you that the change happens only at carbon number 1 and 2. We have an aldehyde here and an alcohol on the second position. Here we switch those functional groups. The first carbon now has an alcohol and the carbonyl is moved to the second carbon. This, as you might have guessed, is a keto sugar. In fact, it's a ketohexose. I'd go further and say it is the keto version of D-glucose. And that's a different sugar. It's a different sugar that's extremely important in your body and your diet. And it's got a different name, and that is D-fructose, or DFRU. So let's just go ahead and make sure you remember that numbering these is always going to start at the terminal carbon closest to the carbonyl. It doesn't start, in this case, on the carbonyl. We start there, number 1. The carbonyl itself is carbon number 2, and we continue on all the way down to carbon number 6. So this is the keto version of an aldohexose called D-glucose, and this is something we call an Aldo keto isomerization, or an Aldo keto isomer pair. And so now we have another sugar, and I would note we actually have 2 more sugars because we could take D-fructose, we could switch all the chiral carbons and end up with L-fructose, which, by the way, is also found in your body. Not as much as D-fructose, but let's note that there are only 3 chiral carbons to be switched. We lost one when we moved the carbonyl to carbon number 2, but nonetheless, D-fructose can be converted to L-fructose by switching all 3 of those. So we just gained 2 more sugars. Let's move on. What is the transformation of D-glucose down here? If you looked closely, I suspect you would see that what happened is we went from right, left, right, right to right, left, left, right. That is, we switched 1 carbon. We switched the chirality of carbon number, well, you tell me, carbon number 1, 2, 3, 4. Now this is a different sugar. It is not D-glucose and it's not D-fructose. What is it? We call this D-galactose, or DGAL, in a 3-letter code. This is not an enantiomer, and it's not an Aldo keto isomer. This is what we call an epimer. Now, an epimer, and we'll write this down later, you don't have to write it now, but an epimer is when you change just 1 chiral carbon. And since glucose has 4 chiral carbons, it's important that we indicate which one we changed. This is the C4 epimer. Now, we just got another sugar, D-galactose. In fact, we got 2 sugars because we could easily take D-galactose, which is right, left, left, right, and we could switch all the chiral carbons to left, right, right, left, and we'd have L-galactose. So we actually get 2. And this is yet another sugar that's found in our body and very important in our diet. Generally, epimers are pretty easy to work with. And I'd like you to practice this by drawing out the Fischer structure of the C2 epimer of glucose. Start with D-glucose, and we are going to make the C2 epimer, which has a name. It's a different sugar, important in your body. It's called D-mannose, or DMAN. And I'd like you to draw the Fischer structure of that. Pause the video and we'll come back and go through it. Okay, I hope you took this challenge. We're going to draw the D-mannose Fischer projection. And Fischer projection always starts with a vertical line. We're going to go ahead and put on a carbonyl on carbon number 1. We'll go ahead and put a primary alcohol on carbon number 6. And at this point, instead of right, left, right, right, we're going to switch carbon number 2, and we're going to end up with left, left, right, right for those chiral carbons. Let's just make sure you see it. 1, 2, 3, 4, 5, 6. Notice that it was number 2 that we switched from right to left. This makes mannose, and mannose, like I said, is a key sugar we'll see in more advanced types of carbohydrates. So I wonder if you picked something up. I did this on purpose. Notice in D-glucose we have the OH going to the right, and here in mannose I made it to the left. Maybe you drew it to the right. Well, like I said earlier, either way is fine. So I did that on purpose just to remind you that the carbonyl up here on carbon number 1 can be facing right or left, it doesn't matter. Same thing with this down here, it can be swinging around and it can go to the right or left, it doesn't matter. It's these chiral carbons here that are really critical for us to get right in a Fischer projection. So if we make a new sugar called D-mannose, don't forget we've got L-mannose as well. It's easy, and these are sugars I expect you to be familiar with. D-glucose, D-fructose, which is simply the keto version of that, D-glucose, which is the C4 epimer, and D-mannose, which is the C2 epimer. Notice how all of these sugars are just derivatives of glucose. In fact, that's what we do in the body. We take glucose and make an isomerization of carbon number 1 and 2, and we get fructose. We can switch a single OH in the body and make galactose, or a different one and get mannose. So it's a useful way to think about it, is to start and know glucose very well and simply remember the way these transform into other sugars. Okay, that's the end of this page, and it's really the end of our Fischer projections. We'll leave it at that for now and move on to more complex things in the next video.